Hey guys, it's Josh Myers and this is Academia on Demand, and this is our third video, and it is going to be our first skill building video. So in the last video we took a long look at the periodic table, this idea of organization of our elements of chemistry, our fundamental units that we do stuff within the chemistry classroom. So, what I've done today is I've picked out 4 of the major groups, the groups being the vertical rows on the periodic table, to examine more closely, because in order to broaden our perspective of what drawing an atomic structure is, which is the title of this video, we have to be able to examine these groups critically and their atomic structures. And later we will talk much more about exactly what it all means and talk about how it may lead into other videos. So, what have we learned about the alkali metals? One thing we have learned is that they are group 1 on the periodic table. And what does this mean? This means that they have one valence electron in their outer valence electron, meaning that they have one electron in their outer energy level. So for example, let's take who should I take? I'll take lithium. Let's go lithium. Lithium has the atomic number of 3, by the way. Atomic number of 3. And in lithium's outer orbital, outer energy level, once you draw its nucleus, it's got 3 protons and 3 neutrons. In its outer energy level, you got the first energy level, because it is in the second period, so it has 2 energy levels. There's 2 electrons, because for every proton there is an electron when the element is an atom. It does not have a charge. Every proton corresponds with an additional electron. So now in this second outer energy level, this second energy level, there's going to be 1 electron. And this is very important, because this idea of the number of electrons in the outer energy level is going to play a very important role in exactly how the alkali metals will bond with things such as the halogens that we will talk about much later. And this will be very important for any sort of chemical reaction, this thing that happens where two elements will interact with each other, and something will happen where the electrons, they will go through a process of maybe sharing, maybe giving away, but there will be a transfer of some sort of electron transfer from one place to another when a chemical reaction happens, and that will correspond to what this thing we call a bond. But not quite there yet. Now we have to talk about some of the other groups, and then we will talk about what this thing called a bond in a chemical reaction is. Very mysterious. So now, the alkaline earth metals, they are group 2, and just as the group 1s were the alkali metals, they have 2 valence electrons. This number corresponds to the number of valence electrons in the outer energy level. And so let's look at magnesium. And we'll draw just the electrons, because this orbital, this nucleus will get very big, and I don't want to draw 24 different particles inside the nucleus. That is not what I want to do. So let's just draw circle. By the way, one thing I forgot to mention is that this idea of the energy levels being around, this is not technically the way it is, but it is the idea, it's what I want you to think of, way I want you to perceive atoms as of now in this channel. Later we will diversify this perspective, make it more true. For now, I want you to think of the energy levels as circles that go around the nucleus. So magnesium is in the third period, which means it has 3 energy levels that contain electrons. And as we recognize from previous videos, this is the picture of the atom that I gave in the first video, that Bohr gave in his discovery of energy levels. This is the basic nuances of the picture. So this is nucleus. Let's just draw a few protons and neutrons, even though we know there are many more in the magnesium nucleus. And now we will start to fill up the energy levels. So we know that in the first energy level, there's only 2 electrons, as given when we looked at how hydrogen and helium are the only elements in the first period that corresponds with the filling of the first energy level. And that is exactly organized that way by design. So now magnesium, we have to fill up the second energy level, and there are 8 elements in the second period, which means that there will be 8 electrons. 8 electrons in the second energy level. Second energy level, filling more electrons. Alright, we have 8 electrons. Okay, so now we come to our last energy level, our outermost energy level, what they would call here the valence energy level. And we are going to add, uh-oh, I put these the wrong place. That is bad. That's called making not magnesium. That's not what magnesium is. We have to put them in the right energy level. Otherwise, chemistry gods will be upset with us. Okay, sorry. I'm fixing. Okay, so now add these. Add electrons. Okay, so now the outer energy level, because of the idea the alkaline earth metals are group 2 element, group 2 metal, alkaline earth metal, that means that they will have 2 valence electrons, so two electrons. And so from our perspective, from what we understand about atoms and their structure so far, this is exactly what they look like given the nucleus, and then moving outward to draw the electrons according to the number of elements in a period, so filling up the energy levels. The energy levels always, if they had feelings, again, I'm going to go back to feelings because I'm a touchy-feely guy, they want to fill up their outer orbitals. And this has a lot to do with the physics of energetic stability. So now let's examine. We're done with alkaline earth metals. Let's examine the halogens. Halogens are group 7. There are group 7 elements, and they correspond therefore with 7 valence electrons. 7 valence electrons. Okay. So now, in order to do an example of this, let's choose fluorine. Fluorine is the most reactive element in the periodic table, and we will talk a lot more about reactivity later on in this video and then in future videos. And so let's draw the atomic structure of fluorine. So first thing that we always do, as I've been doing, is we are going to look at the period that fluorine is in. Fluorine is in the second period. So what this means is that there are 2 energy levels present in fluorine that have electrons in them, that contain electrons. So Let's draw the fluorine nucleus. We have 9 protons and 10 neutrons. Just going to let everyone know. Hold on, let's make this better. I made a mistake. Alright, let's go bigger nucleus. Alright, so protons equals 9, and neutrons equals 10. So now we are going to draw the energy levels around. So the first energy level, as we know, again, it's going to have 2 electrons, and that is because it's not because of it, but the way the periodic table has been organized, the first period has 2 elements in it. And this corresponds to the filling of the first energy level, and that is very happy. Fluorine wants that. So now let's draw the second energy level, the outermost energy level, in fluorine. Alright, drawing energy level. And these are considered, the idea of them is that they are the paths that the electrons can travel in the atom when they are using the word orbiting the nucleus, when they are in an attractive state with the nucleus, because obviously electrons have a negative charge and protons have a positive charge. So unlike charges attract, they will attract each other. However, electrons still will travel in these energy levels. So now we have to add 7 electrons. 7 electrons. 7 electrons. Oh, no, that's 8. Oh, I don't want to add 8. I want to add 7. So we have the absence of an electron here. There. We have the absence of an electron there. And that is the atomic structure of fluorine. And so now we're really coming to see exactly how these elements differ from one another, in the sense that fluorine has almost a nearly full outer energy level. It has this energetic affinity, this desire to fill this outer energy level, whereas lithium only has one electron in its outer energy level, so it has a desire to give away this electron, so that there are only electrons in its first energy level, and thus it would have a full valence energy level, full valence level. So that now that we're starting to see, can we make a connection between this? Could lithium give away an electron? Could it transfer its electron to fluorine? Because then they'd both be very, very happy. If they had faces, they would be smiling, because when that happens, lithium empties its second energy level so that it only has a full first energy level, whereas fluorine gains this electron and completes its second energy level. And when this happens, this is called a chemical bond, where they are both more stable in that bonded state than they are not bonded, when they are not in a bonded state. And they share the exact same, they share the electron makeup, the idea of the full outer energy level. They share this with the naturally occurring noble gases, who have 8 valence electrons, 8 or 2 if you're helium, 2 if you're helium, but 8, most of the time 8 valence electrons. We will talk about later, obviously, if orbitals will change that perspective a bit, but for now they have 8 valence electrons, because when you move from the group 1 all the way to group 8 across the periodic table, ignoring the transition metals, there are 8 elements in each energy level, and that is the way I want our viewer, our learner, to think right now. So let's choose neon. No, let's not choose neon. Let's choose helium. That stuff you suck in when you're at birthday parties. It's very fun. Okay, so now helium nucleus. helium nucleus has 2 protons and 2 neutrons. And it has 1 energy level corresponding to the idea that it's in period number 1 in the periodic table. It has 2 electrons because the number of electrons is always equal to the number of protons when there is no charge on an atom. So this idea now is that it has a full outer energy level, and so therefore helium is in the energetically stable state of having its outer valence energy level filled with electrons. It is very happy because of this. So this idea that I previously introduced with lithium giving away an electron to fluorine, this is what happens in this thing we call ionic bonding. And in the next video, we are going to look at exactly how all this bonding stuff happens. From, again, the simplified view of these circular orbitals. We will later diversify this, but for now, talk to you later. Bye.